let's review a little bit on chapter 7 and 8. And there is one type of problem. It says find the probability. Now sometimes that's find the proportion, percentage, so forth, but basically find the probability. And this is the normal distributions. The first one that we have is where we have one whatever. And this is where we just remember if our normal distribution, what's a new page here? We're going to do our normal distribution. Our first value is the x, and then our mean, standard deviation, and cumulative. So for this is going to be our normal distribution. We'll put it in our x value, we'll put it in our mean, we put it in our standard deviation, and then we'll put in our flag. And I'll put F for flag. You know, 1 for cumulative. Actually, everything we do is cumulative in that. Then we have another type that are many whatevers. Instead of talking about a single person or single book or something like that, we're talking about like 30 books, and we're finding the average number of pages. And this is going to be a normal. I hate this pen. Maybe it's my other. Maybe it's a pen. Let me go to my other one. There it goes. And well, what do you know? It looks like it is my other pen. Okay. We have our x value. We have our mean, and then we have our standard deviation divided by the square root of n. And then we have our flag, which we'll put 1 in. And then we have the type where it says use the normal as an approximation to the binomial. And it'll actually say those words. I don't put any tricky problems on there where you have to kind of decipher that yourself. So normal is an approximation of the binomial. And this will be the norm dist. And I'm going to put x here, but this is with the 0.5 correction. So this is that 0.5 thing. And then we're going to have our mean, which is n times p. And then we'll have our standard deviation, which is the square root of n times p times either q or 1 minus p, however you want to think of it. And then f for our flag. And again, we'll put 1 for the standard deviation there. Then our second type that we'll be looking at is find the value. Doesn't say find a probability, percentage, proportion, or anything like that. It actually says find a value. And this is going to be our norm INV. And I'll put in ATR, area. Let me try it again. ATL, area to the left. And then our mean. And then our standard deviation. I think that's the only flag. So let me go check this. Let's see. Norm INV. Yeah, those are the only ones. So this flowchart we're going to use. So let's take a look at some problems here. Assume that the heights of men are normally distributed with the mean of this, standard deviation of this. If 64 men are randomly selected, find the probability that they have a mean height between 60 and 78. Find the probability. So we're sitting here at this box right here. One whatever. Well, we're talking about 64 men. So we're talking about the many whatevers. So this is how we're going to plug it in. So let me come over here. For our first problem, we'll do norm dist. And it says mean between 60 and 78. Well, remember, this is where we have to do the 78, and then our mean, which is 69, standard deviation, which is 2.8, divided by square root of 64 minus norm, dist, and the lower one, which was 60. This is between 60 and 78. Then our mean, and then our standard deviation divided by the square root of n. And I didn't put a 1 on that first one, did I? Okay, this needs a 1 here. There we go. And then press enter. Now, of course, I made these numbers up when I came up with the test, so it comes up with a pretty bizarre here thing. Between 78, or between 60 and 78, when you take in all the rest of the count, then very well could equal what you see there. Let's look at our second one. Distribution of cholesterol levels in teenage boys is approximately normal with mean of this and standard deviation of this. Levels above 210 warrant attention. Find probably that a teenage boy has a cholesterol level greater than 210. A teenage boy. Well, we're over here to find a probability, and it doesn't say normal is approximation of binomial. It's not the many whatevers. We're talking about a teenage boy. So we're talking about just one whatever. Greater than 210. Well, if you remember this from the homework, greater than 210, we do 1 minus, and then norm, dist, 210, our mean, which was 170, standard deviation of 30, and cumulative would be 1. And that'd be your answer. Now, the idea here in this review is not to teach you how to do these, because you did that in the homework, and the videos for that. This is they're all mixed together. How do you tell what to do in which part? Okay. A telemarketer found that there was a 1% chance of a sale from his phone solicitations. Found probably getting at least 10 sales for 1,000 telephone calls using normals and approximation of the binomial. Normals and approximation of the binomial. So find a probability, normals and approximation of the binomial. We're going to do this one. Now, at least 10 sales. Let me actually draw this one. At least 10. Here's 10. At least 10 includes 10. So I'm going to subtract 0.5. Because I'm shading this way. And again, if your wording includes 10, your shading has to include 10. So 9.5 is the one we're going to work with. But remember, Excel has to be to the left. So I'm going to come over here. And this will be equals 1 minus norm, dist. What did I just say? 9.5. 9.5. Our mean, which would be n times p. 1,000 telephone calls. 1,000 times p. 1% chance of a sale. So 0.01. Comma, then square root of 1,000 times 0.01 times 0.99, comma 1, like that. Okay, so let's look at our fourth one. Assume the salaries of elementary school teachers in the United States are normally distributed with the mean of this, standard deviation of this. If 80 teachers are randomly selected, find the probability that their mean salary is less than 30,000. Find a probability, and we're talking about many whatevers, 80 teachers. So this is one we want to use. We just basically want to divide our standard deviation by the square root of n. Is less than 30,000. So less than 30,000 equals norm, dist, 30,000. Our mean, which is something, 32,000. Our standard deviation, which is 3,000. Then our, oops, this is more than one, wasn't it? 80 teachers. So we have to take our standard deviation, divide by the square root of 80. And then 1 for cumulative. And again, that's a really small probability, but I made these numbers up, so they don't come up with things might be normal. Okay. Problem 5. Assume the heights of men are normally distributed with the mean of this, standard deviation of this. The top 5% and bottom 5% are excluded. For experimental, what are the cutoff heights to be eligible for this experiment? Round your answer to 1 decimal place. What are the cutoff heights? Find the value. We're going to use norm INV. Well, if I'm saying 5%, in the bottom 5%. So what they're telling us is they're telling us there's 5% here, and there's 5% here. Well, that's 10%, so that means 90% would be here. We're going to have one value here, and we're going to have one value here. Now this is going to be the norm INV, the area to the left, which would be 0.05, and then our mean, which was 68.9, then our standard deviation, which was 1.7. And this one will be norm INV. The area to the left will be the 0.90 plus the 0.05. So it'll be 0.95. Then our mean, which is 68.9, and our standard deviation, which was 1.7. Jeez. 1.7. There we go. I won't actually plug those in since you got it written down there, but okay. Number 6. An airline knows that the from experience, the distribution of the velocity each week is approximately normal, with the mean of this, standard deviation of this. What is the probability that during a given week the airline will lose less than 15 suitcases? So we're talking about one airline, in less than 15. So we're over here. Probability, one whatever. We're going to use this first one. So this is number 6. I'm not being lazy on that one. I'm just running out of time. These can only be so long. Less than 15. So 15, comma, our mean, which is 15.5, comma, 3.6, cumulative 1. And last one. Length of pregnancy is normally distributed, the mean of this and standard deviation of this. If 36 women are randomly selected, find the probability that they have a mean pregnancy between 250 and 271 days. Probability, and we're talking about 36 women, so many women. So we're going to use this one. We're divide the standard deviation by the square root of n. So let's see, 271. So equals norm dist 271. Our mean, which was 267. And then our standard deviation, which is 15 divided by the square root of 36, comma 1, minus norm dist 250, and 267, and then 15 divided by the square root of 36, comma 1. And that'll give us our answer. So again, this flow chart is what you use to decide what to use in what circumstance.